In this section, we're going to talk about our end goal is going to be partial fraction decomposition. But to get to that goal, we need to talk about proper fractions and improper fractions and do a quick review of long division. So for the first part, I'm just going to stay in arithmetic, and then we're going to move into algebra so you can kind of see the correlation. So what we have for a proper fraction, what do we term a proper fraction? That's where your numerator is bigger than your denominator. So something like 1/3. Okay, 1/3 is a proper fraction. Why? Because your numerator is 1, your denominator is 3, and your numerator is smaller than your denominator. So that's proper. Okay, so now what about if I have something like 7/4? Okay, we're going to declare that to be improper. Why is that improper? Because your numerator is bigger than your denominator. Well, something that you learned way back when is how do I change an improper fraction into something that contains a proper fraction? In other words, can I make this into a mixed number? Okay, and I can divide. So I can take 4 and I can divide it into 7. Okay, so the top number goes in the little box, bottom number goes on the outside. So I'm going to take 4, see how many times it goes into 7. So 4 goes into 7 one time. Okay, so now what do I do? And I know this is kind of simplistic. I'm going to take this 1 and multiply it times everything out front. So 1 times 4 is 4. Okay, now what do you do? Now you subtract. Well, in algebra, when we subtract, we change all the signs. So in this case, instead of having a positive 4, I have a negative 4. So 7 minus 4 is 3. How do I know when to stop? Well, 4 is bigger than 3. So that's how I know when to stop in arithmetic. So we're going to cover this again in a second with algebra, but for right now, how do I know when to stop? I know that 4 is bigger than 3, so I need to make a decision. I've got one of 3 options. I can either keep going and go into decimal land. I can simply say R3 and make remainder of 3, or I can write my remainder as a proper fraction. So what I would say is 4 goes into 7 once with a remainder of 3 out of 4. So I changed my improper fraction into a mixed number. So these two things mean the same things. They just look completely different. They have the same meaning. Okay, so I know what a proper fraction is in arithmetic. I know what an improper fraction is in arithmetic. I reviewed long division real quick, and I realized how to write my answer. One of the things that you can do with that answer is I could put a little plus sign here, right? Because think about a cup of sugar. A cup of sugar plus 3/4 of a cup of sugar is a cup and 3/4 of a cup of sugar. We're going to need that plus sign when we go into algebra. Okay, so I know what a proper fraction is, I know what an improper fraction is, and I know what long division is, but I've couched all of that in arithmetic. So now let's move to algebra for a second. We're going to compare degrees on our numerator and our denominator. So just quick review, the degree of your polynomial is the largest exponent it has. So if I want a proper fraction in algebra, which we would call a rational expression, okay, all of these are rational expressions in algebra. Okay, so if I want a proper fraction, what I'm going to look is I'm just going to compare the degrees. So for instance, if I have x plus 2 over x to the 7th minus 4x squared plus 1. Okay, the degree on top is a 1, because there's a 1 right there. The degree on bottom is a 7. So this is not 1/7. I'm writing the degrees. So because the degree on top is smaller than the degree on bottom, this is proper. Okay, so the numerator is smaller than my denominator. So what does an improper one look like? Well, an improper one will be something like, and I'm just making stuff up. Okay, an improper one will be like, well, let's just flip it. X to the 7th minus 4x squared. We'll make it exciting. minus 13x plus 2 over, and I can do x squared plus 14. Okay, so what's my degree on top? My degree on top is a 7. My degree on bottom is a 2. So the degree on top is larger than the degree on bottom, which means this is improper. Okay, so what I can do is I can fix it and turn it into the equivalent of an arithmetic mixed number. So now what we're going to do is we're going to refresh ourselves on how to do polynomial long division. And I'm not going to do this one because it'll take us forever. So here's what I'm going to do. I'm going to make up another one. And we're going to do a smaller version. Okay, so what I have right now is I've got an x to the third plus a 2x squared minus a 16x and then plus 16 over, and I've got x squared plus 3x and minus 18. Okay, so the first thing I want to know is, hang on, I'm down here. Okay, so the first thing I want to know is this proper or is this improper? And this is going to be improper because my degree on top is a 3 and my degree on bottom is a 2. So my numerator is larger than my denominator. So what I'm effectively going to do is do some long division, and then I'm going to rewrite it as a polynomial with a rational expression at the end. Okay, so what I have is, there we go. What I'm going to do is this. I'm going to take the thing on the bottom and put it on the outside, and take the thing on top and put it on the inside of my division. Okay, so what I have right now, and actually I'm going to change papers so I have enough room. What I have right now is an x squared plus a 3x minus 18. And I'm going to divide that into x to the third plus 2x squared minus 16x plus 16. All right, so our process is the exact same. So what I'm going to do first is estimate. One of the things you better watch out for is everything on the inside of this division needs to be in descending order with no missing steps. Okay, so I've got x to the third, x squared, x to the first, no x. So x3, x2, x1, no x. So that's in proper descending order. I don't care if there's stuff missing over here. In other words, if that 3x was missing, I wouldn't care. Okay, but I do need placeholders in here. All right, so what I'm going to do is I'm going to estimate first. So I'm going to take the first term into the first term. So I got an x squared. What do I multiply x squared by to get to an x to the third? So ignore everything else on this paper. What do I multiply x squared by to get x to the third? Well, I multiply it times x. So I'm going to put an x up here. And now what do? I take what's on top and multiply it by everything out front and put my answer in the proper column. Okay, so I'm going to do x times x squared is x to the third. So I'm going to put that in the x to the third column. I'm going to take x times 3x, and I'm going to get 3x squared. So that goes in the 3x squared column. So notice my x to the third lined up. I'm combining like terms is what I'm doing. And I've got an x squared lined up. So that I've got an x times a negative 18 is a negative 18x. So I've taken the top and multiplied it times everything out front. Now what do you do? What did we do here? We changed the signs because we've got to subtract. So remember in algebra, you're going to change your signs all the way across. So this becomes minus, minus, plus. So your first term should fall off. If it doesn't, you've done something wrong. So x to the third minus x to the thirds, no x to the thirds, we're good. So 2x squareds minus 3x squareds is a negative 1x squared. Negative 16 and 18 is a positive 2x, and then I've got a plus 16. Okay, so my question a while ago was how do I know when to stop? Okay, so come back over here for a second. I knew to stop here because this number was bigger than this number. Well, we're just going to compare degrees instead of values. Okay, so this degree, this degree is the same as this degree. So this is my last round. I'm going to go ahead and do this one, and I'm going to stop, regardless of what I get. Okay, so ignore everything else. We're going to take the first term, and I'm going to say, what do I multiply it by to get this? Well, x squared, to get a negative x squared, I need to multiply it by a negative 1. Okay, so take that negative 1 times everything out front. So negative 1 times x squared is a negative x squared. Negative 1 times 3x is a negative 3x. Negative 1 times negative 18 is positive 18. And then what do? You change your signs. So because we're subtracting. So plus, plus, and minus. I just broke my pen. All right. First term should fall off. If it doesn't, you've done something wrong. So negative x squared plus x squared is no x squareds. 2x's and 3x's is 5x's. And 16 minus 18 is going to be a negative 2. So now, again, I already said that was going to be my last round, but now look, x squared is bigger than x to the first. So do not continue. Don't look at your coefficients. This is a 1, this is a 5. I don't care about that. Compare your degrees. So x squared is bigger than x to the first, so stop. So how do I write my final answer? My final answer, okay, is the quotient, which is on top. So I've got x minus 1, and then my remainder is 5x minus 2 over what I divided by. So x squared plus 3x minus 18. So that's exactly what we did over here. Your answer was your quotient, which is on top, and then your remainder, which was 3, over what you divided by. But here's where this little plus thing is going to come in. You will always, always, always put a plus right there. Do not put a minus, because it'll throw stuff off. Okay, so I'm going to add whatever my remainder is over what I divided by. So what we end up with is this was the quotient, and this is the remainder. Okay, now I'm going to backtrack for just a second. And I'm going to rewrite the exact same problem again. Okay, so if I had x to the third plus 2x squared minus 16x plus 16 over x squared plus 3x minus 18. Okay, I could have just seen if it reduced here. Okay, so come back over here. Did 7 and 4 reduce? No, it didn't, because they didn't have any common factors. Okay, but what happens if I give you a different improper fraction? What happens if I give you something like 24 over 6? That reduces. Okay, they have common factors of 6. So I could rewrite 24 as 4 times 6 over 6, and then my 6's reduce out. My answer is 4. So notice there's no remainder here. Okay, what is 24 divided by 6? It's 4 with no remainder. So what happens is you'll find out that if you've got a remainder, this thing did not reduce properly to begin with. Well, what happens if we try and factor this? I can try and factor this using grouping. So I could pull out just the top part. I can pull out an x squared from my first two. And that leaves me with x plus 2. Well, what's common on the second two? I can pull out a negative 16. That leaves me with an x minus 1. My parentheses don't match. Okay, I cannot use factoring by grouping on this. And so if my parentheses matched, I could continue to go forward and see if it reduces with something on the bottom. For instance, your denominator factors down to x plus 6, x minus 3. So if you had a common factor, you could reduce it. Okay, and then if it didn't reduce all the way, you would still have to do long division. So in issues like this, you might want to just hit long division first. So we now know what a proper fraction is, or a proper rational expression. We know what an improper rational expression is. And now we know how to do long division if it was improper to start with. So the second part of this video, we're going to go in and do some partial fraction decomposition, and I will explain that when we get to part 2.